Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 6 to 10 of the January 2018 Algebra 2 New York Regents exam. Alright, let's take a look at question 6. It reads, the expression quantity x plus a times quantity x plus b cannot be written as. So basically, which of these forms, these expressions, is not equal to this expression that's given right here? Okay, so let's go ahead and start off by expanding this expression completely, and then we can start to make our comparisons. So the factored form of this expression is x plus a times x plus b. Okay, now what does the expanded form look like? To get the expanded form, all we just simply have to do is we're going to distribute twice. We're going to multiply the x by x and b, and then we'll distribute the a to the x and b. Okay? Alright, let's go ahead and carry out that expansion. X times x is x squared. X times b is bx. And then x times a is ax. And then a times b is ab. Okay? So this is the expression in its expanded form, and it has been simplified completely because no further simplification can be carried out. Now let's take a look at option 1. We have a times x plus b plus x times x plus b. Now if you take a look at this, we can factor this by grouping. Okay, just divvy down the center. Now what you have is you have two identical quantities. You have x plus b and x plus b on both sides of the partition. So what can that enable us to do? We can factor it out as one, x plus b, and then we have on the outside a and then x. So that is a plus x, which can also be written as x plus a since addition commutes. Okay, so this is equal to the factored form of the expression given to us. So expression 1 is exactly the same as what we were given initially. But if you take a look at expression 2, we have x squared plus abx plus ab. Guess what? This is not equal to this original expression, because when we compare this to the expanded form, we have x squared plus, let's switch these around, ax plus bx, we know addition commutes, plus ab. Okay, ax plus bx is not equal to abx. This is false, so the answer to problem 6 is option 2, because it's not equal to this given expression here. Alright, let's take a look at problem 7. It reads, there are 440 students at the Thomas Paine High School enrolled in U.S. history. On the April report card, the students' grades are approximately normally distributed with a mean of 79 and a standard deviation of 7. Students who earn a grade less than or equal to 64.9 must attend summer school. Question: the number of students who must attend summer school for a U.S. history is closest to. Alright, so let's start by taking a look at the steps that will guide our problem solving process for this problem. So what we'll do first is we're going to find the percentage of students that scored 64.9 or less. Okay? So step 1 is find the percentage of students we're going to be using the normal cumulative distribution function on our graphing calculators. Alright? Alright, so after we use our calculators to determine that percentage value, we're then going to proceed to find the number. Okay, find the number of students that meets the criteria. So with the percentage and the total, we can determine the number of students. Okay. So how do we use this function right here, the normal cumulative distribution function with the information that we have? Let's review the syntax for accurately entering the information into the calculator. So syntax for the normal cumulative distribution function is as follows. So first of all, you call up the normal cumulative distribution function on the calculator. I'll demonstrate it in a second. And then the first entry is your lower bound. You enter your lower bound. The next entry is your upper bound. The next entry is your mean. And the last entry is your standard deviation. Okay? So that's basically the syntax for using the normal cumulative distribution function of the TI graphing calculators. Okay, so let's go ahead and execute these steps in this problem. So let's start off by determining the percentage of students that earned a grade of 64.9 or less. So for step 1, we want to find percentage of students with 64.9 or less. Now, how can we represent this using an inequality? If you have a score of 64 or less, 64.9 or less, that means that your score is basically between 0. It could be 0 or anything between 0 and 64.9, including 64.9. So it's basically 0 less than or equal to the score, and the score less than or equal to 64.9. So 0, 64.9, and everything in between represents your interval. Okay? So with this interval, we can determine what our upper and lower bounds are. Our lower bound is 0 because you cannot have negative scores on a test, right? You can have a negative grade. Alright, lower bound is 0, and then your upper bound is 64.9. So for the syntax, you notice we need the lower, upper, we need the mean and standard deviation. And then our mean is given by the value 79, and our standard deviation is 7. Okay? Alright, so with this information we can calculate the percentage of students with 64 or less. Alright, so percentage of students is going to be, now in the calculator, let's now apply this formula. We're going to enter normal cumulative distribution function, parenthesis, the lower bound is 0, comma, upper bound 64.9, comma, the mean, which is 79, comma, standard deviation, which is 7, and then let's see what we get. Alright, so fire up your calculators. To access the normal cumulative distribution function, you can go to catalog, or you can go to this distribution feature here, accessible by pressing second function variables. So let's do that faster. Second function variables, and then we have the probability and cumulative distribution functions. We're looking at the second. So go to 2 and press enter, and then we have the values to enter into the function. Lower bound, comma, upper bound, comma, mean, comma, standard deviation, enter. Okay, oh, I didn't put in the 9. Let me do that again. So I need to insert a 9 after the 64. So 64.9. So let me insert the 9 there. Okay. All right, so there goes your percentage. So it's approximately 0.22. Um, so it's 0.022%. So let's write it as decimal first. So 0.022. So in decimal form, that's equivalent to 2.2%. Okay. Now, 2.2% is achieved by moving the decimal to the right 2 places. Okay, that's how you convert from decimal to percentage. We're done with the first part, which is the computation of the percentage of students that scores 64.9 or less. Now, the second part is to get the exact number. Okay, so now let's calculate the number of students. How do we calculate the number of students? You just take the percentage and multiply it by the total. Okay, so we're going to look at 2.2% of the whole 440. So that's basically 0.022 multiplied by 440. Alright, we already have the decimal form of the answer in our calculator, so all we just do is press times. So it calls up our previous entry, multiply that by 440, and then we have 9.67 or 9.68. So 9.68. Okay, so if we want to round this up, this is going to be to the nearest, to the ones place. Nearest whole number is basically approximately 10. Our answer to question 7 is option number 3. Okay, so 9.68 is closest to 10. Alright, let's take a look at question 8. It reads, for a given time, x in seconds, an electric current y can be represented by y equals 2.5 times the quantity 1 minus 2.7 to the negative 0.1x. Question, which equation is not equivalent? Okay, so which equation is not equivalent to this equation that we have up here? Now, before we get started, let's do a real quick review of our properties of exponents. Okay, so you want to recall the following properties of exponents. The first one is the product property. What if you have the product of two exponents with identical bases? What's the rule? This is you basically add the exponents. Okay. How about if you have a power raised to a power? This is known as the power of a power property of exponents. In this case, you just multiply the exponents. Okay, when you have products of powers, you add the exponents. When you have the power of a power, you multiply the exponents. Okay, what if you have an exponent as a denominator? You can reciprocate the term that's in the denominator, but how does that affect the exponent? It's negated. Okay, so whenever you reciprocate an exponential term, the exponent achieves an opposite sign. Okay, so with those points in mind, let's go ahead and see which of these is not equivalent to that. Okay, now let's start with the first one. You notice we have a common factor here, 2.5 and 2.5. That can be factored out. So we are going to have 2.5 times, if you factor out 2.5 from 2.5, you have 1. And then here you also have 1, but when you multiply it by this 2.7, you still have 2.7 raised to the negative 0.10x. Is that equivalent to what we have here? It certainly is. So option 1 is equivalent. Option 2, we can start off by factoring out these two identical numbers. Again, common factors. We can factor those out, 2.5. And we have 1 minus, and then we have, check this out, a power of a power. So power raised to a power. So what do we do in that case? If you have a power of power, what you do is you multiply the exponent. So we multiply the power. So 2 times negative 0.05x. Alright, and then to simplify it, we just have 2.5 times 1 minus 2.7. Now 2 times 0.05, you can work that out in your calculator, is just going to be 0.1. Okay, so it's going to be negative 0.10x. Is that the same as the original problem? It certainly is, so this is also equivalent. Let's move on to option 3. We can factor out 2.5 again, so factor out 2.5, and then we have 1 minus, and then we have an exponential term that's in the denominator. Okay, so 0.1x. Now what happens if we reciprocate this exponential term? If we reciprocate it, we're going to have 2.5 times 1 minus 2.7 using the reciprocal property of exponents. When we reciprocate, the exponent achieves an opposite sign. So since it was positive before, now it becomes negative 0.10x. Compare that to the original, is exactly the same, so this is equivalent. So we can see that the answer should be option 4. But let's make sure that that's the answer. Let's go ahead and simplify this. Okay, we can factor out 2.5, so we have 2.5 times 1 minus, now we have the product of two powers with identical bases. What's the rule there? Well, let's write it down first, and then we're gonna apply the rule where you have the product of powers property. Okay, so we have 1 minus 2.7 raised to the negative 2 times 2.7 raised to the 0.05x. Now what's the rule when you're multiplying two powers with identical bases? You simply add the powers. So we have 2.5 times 1 minus 2.7 raised to the negative 2 plus 0.05x. That's the simplified form. Is it equivalent to that? Absolutely not. That's why our answer is option number 4. Alright, let's take a look at question 9. It says, what is the quotient when 10x to the third minus 3x squared minus 7x plus 3 is divided by 2x minus 1? So this is a long division problem. When they ask for quotient, they're asking for what you get when you divide this divisor by this dividend. Okay? Alright. Okay, so let's go ahead and do it. We have 10x to the third minus 3x squared. Now whenever you're setting up your long division, you have to remember that the terms have to be written in descending order of degrees, and missing degrees have to be addressed using a placeholder. So we have 3, 2, 1, 0, so we don't have any missing degree terms. If we had a missing degree term, we'll just put a 0 as a coefficient and attach that variable with a missing degree. Okay? But that's not applicable here, so that makes it easier to do. Okay, so whenever you're dividing a binomial, or you divide in this case a quartic, it's not a quartic, this is a cubic polynomial with 4 terms. So if you're dividing a cubic polynomial with 4 terms by binomial, you take a look at the number of terms you have in your divisor. So your divisor has 2 terms, so you're going to be attacking this 2 at a time. Okay? But to determine what comes first, you look at the first term in the first 2. So we have 2x minus 1, and then we have 10x to the third minus 3x. So take a look at 2x and 10x to the third. And then you ask yourself, how many times does 2x go into 10x to the third? If you can answer that question, the question you ask yourself is 2x times what gives you 10x to the third? Okay? Alright, so let's see. 2 times what gives us 10? 2 times 5. and then x times what gives you x to the third, x times x squared. Okay? Or you can just say 10x to the third divided by 2x. Let's do that on the side here. You can say, oh, 10x to the third divided by 2x. Uh, so 2 goes here, 1, 2 goes here, 5. You have 5. And then when you divide in exponents with the same base, you subtract the powers. 3 minus 1 is 2. So 5x squared. So that's another way to get it. Okay? Now what we're going to do is distribute this 5 across these two terms. Okay, and then we're going to place the answer right here, and then we're going to subtract. Remember, division is repeated subtraction. Okay, that's basically what division is. So when you distribute, you're going to have 10x to the third. 5 times 1 is minus 5x squared. Alright, when you're doing long division, whenever you select the appropriate quotient term, and you distribute it to the divisor, these first terms must always be the same. Okay, that's a way of checking that if your work is correct. Now let's go ahead and subtract that factor. So we have parentheses, we're going to subtract. Alright, so we have a minus here. So when we're minusing, is the same thing as adding the opposite. So we'll just distribute this minus across both terms. So this becomes a plus, this becomes a minus, and this becomes a plus. When you add downwards, this becomes a 0, and then negative 3x squared plus 5x squared is positive 2x squared. Okay, so we are attacking this problem 2 at a time. We have only one term here, so what do? We bring down the next term 1 degree less, so 2x squared minus 7x, and then we'll repeat the process again. So 2x goes into 2x squared how many times? Or 2x times what gives you 2x squared? Signs are the same, so we have plus. So so basically 2x times x gives you 2x squared. Or you can compute 2x squared divided by 2x, and you see that your answer is just x. Okay, because the 2's divide out, and then you just subtract 1 from there. X to the 1 is just x. Okay, and then you distribute again. X times 2x is 2x squared. X times 1 is negative 1x. And then we're going to subtract. Okay. Having executed these steps, can we eliminate some options? 5x squared plus x. Oh yes, we can eliminate 2 and 3. So our answer should either be 1 or 4. Okay, so repeat the same process. Before we do that, we haven't subtracted yet. So let's subtract. Okay, so we're going to distribute this minus across these two terms. So this becomes a plus, this becomes a minus, and this becomes a plus. Add downwards, we have negative 6x. Bring down the 3. Okay, when we determine the last term in the quotient, we can stop there. We don't need to find the remainder. Okay, all we need is just a quotient. Alright, so let's see. Bring down the positive 3. So the next question is 2x goes into negative 6x how many times? Or 2x times what gives you negative 6x? The answer is negative 3. Okay, if you divide negative 6x by 2x, you get negative 3. You want to check it out? Let's multiply. Negative 3 times 2x is negative 6x, and then negative 3 times negative 1 is positive 1. Okay, so that tells us that the answer is option number 4. Okay, oh, this right here should be, it's not positive 1. Negative 3 times negative 1 is positive 3. Alright, let's take a look at question 10. It says, Judith puts 5,000 into an investment account with interest compounded continuously. Which approximate annual rate is needed for the account to grow to $9,110 after 30 years? Okay, so let's start off by writing down the formula that will guide our problem solving process. So formula for continuous exponential growth. The formula is going to be amount equals principal times e to the rate times time. Alrighty? Okay, so let's list what we need and what we know, plug it into the equation, and solve for what we need. Alright, let's start with A. What is A? A represents the final amount. Final amount that she desires to have is $9,110. P, what is P? P is the principal or starting amount. Principal or initial amount she starts with is 5,000. E is an exponential number, okay? So E is just E. It's not a variable, it's a constant. It's an irrational number, so let's leave it in that format. R is the rate, interest rate. The interest rate is equal to what? What is the interest rate? That's what we're looking for, okay? So that's the unknown. And then lastly, time. T represents time, and the time constraint is 30 years. Alright, so we know 1, 2, 3, we need to find R. Let's go ahead and plug them into our continuous exponential growth formula. So we're going to have 9110 is equal to 5,000 e to the rate r times time 30. Okay, so all I'm just doing is I'm following this format here. A equals P e to the RT. That's what I'm doing. Okay. Alright, so let's start off by, the goal is to get R by itself. So we're gonna get rid of 5,000 first. Okay. Use natural logarithm to get rid of the E. And then the last step will divide both sides by 30, which will result in the isolation of R, the interest rate, in decimal form. And then we'll finish off by converting that into percent format. Okay, let's execute the steps. Divide both sides by 5,000. 5,000, 5,000. So this divides out. I'm just going to leave this alone for now. And have e to the 30r is 911. Well, we can divide the zeros. Cancel out the zeros. That's easy. 911 over 500. To get rid of e, we're going to use its inverse, which is natural logarithm. So natural logarithm of e to the 30r is equal to the natural logarithm of 911 over 500. So now we can call on the help of our calculators. So these two are inverse functions composed with each other. They take each other out. We have 30r is equal to, so let's see what the calculator has to say here. So the natural logarithm of 911 over 500 is 0.59993. 0.59993. And then last step, to get r isolated, divide both sides by 30. And then what do we get? We get r equals, so let's just do that in the calculator. So just press divide by 30. And then we have 0.0199999. So basically 0.02. So approximately 0.02. So is our answer option 3? The answer is no. That's a trap, okay? Remember, the interest rate R in this format is given in decimal form. So we need to change it from decimal form to percent. So how do you change from decimal to percent? You move the decimal points to the right 2 places, okay? So we're just going to move it 1, 2. So R is 0.02 in decimal form. The equivalent percentage form for 0.02 is R equals 2%. okay, and this is in percent form. So you have to be real careful when you're dealing with the percentage component of exponential growth or decay functions. All right, so the answer to question number 10 is option number 1. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions or comments, just post it in the comment section below and we'll be more than glad to respond. More clips and resources can be found on mathgotserved.com. You can access our playlist using this QR code right here. Thanks again for watching and have a wonderful day. Goodbye.